All right. Well, thank you all for being here today. PCI in politics is probably not the most exciting topic, but I'm hoping to make it an engaging thing today. So yeah, once again, I'm Nicholas Klick. I'm a senior DevOps engineer at ActBlue. You may be wondering, what is ActBlue? ActBlue, we're the largest U.S. political donation platform. We process anywhere between $1 to $8 million a day. And you have probably heard of some of our candidates. We specifically work with Democrats and progressives that's who we support. That's kind of the mission of the organization. And so these are some of the bigger names that are on our platform. This is an example of one of our donation forms. So basically what we offer is a full suite of products for campaigns to raise money. This is an example of our initial contribution form. And it's really customizable. We have a lot of A/B testing that we can do for each campaign so they can kind of improve their funnels, things like that, as well as flexible fundraising tools. And we're doing really well. So far, we've raised $2.2 billion, and most of that has come from small dollar donors. Our average donation is $34. So really what we're trying to do at ActBlue is empower small dollar donors to make a bigger impact in these political campaigns. So far, we've had over 6.8 million donors, and we're supporting over 24,000 campaigns and organizations. A little bit more stats. So we started off in 2004, and in the first quarter of 2016, we reached $1 billion, and 18 months later, we reached $2 billion. So we're doing really well right now because people are voting with their dollars, per se, and trying to enact change that way. So with all this money moving around, we need to maintain a secure and compliant environment. It's important to us to security, and especially PCI compliance is a big thing that we deal with. So PCI, if you haven't heard of it or know what it is, it stands for Payment Card Industry, because those were the kind of original founding group that came up with the standards. It's mainly to manage their liability. But I like to think of PCI is standing for protecting cardholder information. That's a non-standard definition, but that's kind of the ethos that I feel more it's orientated towards the cardholder rather than the payment industry. And DSS stands for Data Security Standard. So this is if you're doing a high amount of transactions, you are typically labeled as a level 1 PCI. And so there's a number of things you have to do. Now when I even say the acronym PCI, a lot of different metaphors and perspectives probably come into your head. One of them is that who cares about PCI? That's one perspective that I've heard. Another one is that PCI is really just red tape. It's just getting in the way of me pushing out features and getting things done. Then there's the PCI doesn't go far enough. It's really just security theater. Just kind of like this gate is protecting the sidewalk is essentially how some people think of PCI. But really, I guess I like to think about PCI as it's about the cardholder. It's a baseline set of standards to protect their personal information, their financial information. And there's basically 3 components to it, and I'm going to just go quickly through this, and then we can get to the technical part of things, which is probably more interesting. But it really consists of scope, compliance, and then the audit. The scope is really important, and if you're either having gone through PCI or maybe your company's considering it, Defining your scope is really important because that is essentially the architecture, whether it's the technical architecture or the human architecture that handles or stores the CHD, which is cardholder data. And defining that scope is important because everything that you have to do for PCI is going to be just about that part of your architecture. So imagine, if it basically allows you to contain all of the standards to a smaller section of your architecture. And like once you define that, then all of your compliance, all your monitoring, all your testing is just around that scoped environment. And you really want to limit that as much as possible. So one way that we do that at ActBlue is that we tokenize the payment information. Basically, when we receive a clear text number, we have a credit card vault which tokenizes that number, encrypts everything, and then we are only dealing with that randomized token from then on out. In all of our other systems, just refer to that token. So we essentially isolate the PCI scoped environment to a limited part of our architecture. The PCI compliance part, there's 12 high-level requirements and over 220 sub-requirements. And it kind of covers every area of the cardholder data, everything from firewalls to SSL ciphers to how your Wi-Fi is configured, security-wise, and the actual physical data, the physical security standards around your data center. And then the audit is really to kind of make sure that you're doing what you should be doing. It's usually on an annual basis, and it ensures that you're following the requirements. It includes some penetration testing, as well as kind of getting you up to speed with the latest standards, because the PCI standards are kind of constantly evolving. And so your auditor kind of helps to remind you, okay, there's these new things that you need to do. So yeah, to kind of go into, basically, I joined ActBlue about 18 months ago, and my first big project was to move our credit card vault. And I'm actually not going to go into it and just say that it was kind of, there were heroic feats involved. And it boils down to, we moved to AWS using Chef and Terraform. Okay, that's really what we decided on doing for a number of reasons. And I'll kind of go into those reasons as part of how we use each one of these technologies. And essentially, like, our focus was to take a multifaceted approach to PCI compliance, where we're leveraging different technologies and basically in order to be compliant, and also to go beyond compliance. And so we're basically combining the usage of Terraform, Chef, and Inspec, and it's all on AWS. And I'll kind of go into each one of these and how they're helping us to be compliant. This is kind of our workflow of how it works. So we run our Terraform commands to actually set up the platform. Basically, it's architected as like a peering system, so we have redundancy across regions. And after it's set up, after we've applied those changes, we converge on those nodes, and then we verify that everything's set up correctly using Inspec. So to kind of go into each one of the pieces here, we on AWS, we're in multiple regions, and we leverage VPCs, which is the virtual private cloud architecture that AWS offers. It basically allows you to configure every part of the networking, the subnets, the routing, all that. And we also utilize a lot of restrictive security groups. And so to kind of, like each one of these, I'm outlining, okay, these are part of a specific requirement. Like I mentioned before, PCI, there's 12 major requirements, and so a lot of these kind of either span requirements or they definitely cover a lot of the sub-requirements. So like the VPCs are part of requirement 1. So is the security groups. We utilize IAM to manage our users and roles, who has access to what resources, stuff like that. And obviously EC2 instances for the actual machines that are running the databases and the app servers. And one good thing about being on Amazon, or I'm sure with Azure or Google Cloud or any sort of a remote cloud environment, is that they completely cover requirement 1 of PCI. So like the physical security aspect is completely taken care of. You don't need to worry about protecting a rack of servers somewhere using their criteria. They also offer a NAT gateway. I'm not sure if you've utilized it. It's essentially a package thing that they offer to allow a secure egress from a kind of private subnet, which is kind of a cool thing, so that you can isolate that environment and it has really no access from the outside. We also utilize CloudTrail, which is essentially traces everything that's happening on your account. And we've hooked up an intrusion detection system to monitor the CloudTrail and also the VPC flow logs to see if there's any sort of activity, going on that we need to be concerned about. How many people here either use Terraform or have tested it out? Okay, so I'm speaking to people. Okay, so yeah, most people here kind of know what it is. And basically, we use it to manage all of our AWS and Fastly configuration. And we found it to be a really, really nice way to get transparency around our orchestration. Prior to this, we had a kind of a problem with certain people knowing that certain things were set up a certain way. And Terraform kind of allows for that transparency of, okay, it's all in code, it's all really clear for everyone to be able to see. We can test it, we can see the changes over time. And the Terraform code actually becomes our change log in terms of how, for PCI, you actually have to track changes and the approval of those changes. It has to be kind of a multi-step thing. So the Terraform really helps with that. Yeah, I mentioned it's really great for the transparency. The plan allows you to see what's going to happen, which is really helpful, and repeatable. You run a command. It's idempotent. It does what it sets it up. So yeah, in terms of our Chef setup, so we use Chef for pretty much everything at the node level, and so we're setting up all of our web servers, databases, all that with Chef. But in terms of PCI, we use Chef to do the server hardening, so uninstalling packages and shutting down ports and things that we don't want. We also use it to set up our centralized offsite logging. And as well, the web application firewalls, vulnerability scans, and secure tunnels that we use are all set up with Chef. And as well, SSH with two-factor, so that we're meeting all the PCI requirements. So in terms of how that works with InSpec, so InSpec, I guess, is anyone here using InSpec with Terraform right now? Okay, 1, 2, okay. Yeah, so we are so InSpec basically automates the compliance checks. So the ability to check to make sure that things are set up as we have specified. It's good for running against remote environments and allows you to kind of test and verify that things are set up correctly. Okay, so I was going to do a little demo, if that's okay, to kind of give a little bit of the flow, but hopefully the demo gods are happy with us here. Okay, so yeah, so let's see. Going to okay, so basically what I want to do is I want to kind of show a couple examples of using inspec with Terraform. And yeah, we'll kind of go into a little bit. I wanted to go over a couple of the commands. So for anyone that doesn't use Terraform, you're going to see Terraform plan, which is essentially allows you to check. It's like a no-op mode or a dry run mode, so you can see like what it's actually going to do. And then you're going to see a Terraform apply, which is actually applying those changes. Okay, so basically, like let's imagine that we had a bastion that I've set up with Terraform, and let's say that I'm getting kind of tired of some of the kind of port scanning that's going on. So I just want to change the port of this the SSH port. I just want to change it. So what I can do right now, if I go into my my inspec code, basically I have a test that right now should pass, and basically it, and I guess to take a few steps back, what I like to do is I like to show you how you can write tests against the PCI spec and do kind of a TDD type of thing with inspec and Terraform. So for PCI requirement 1, you're supposed to install and maintain a firewall to protect cardholder data. And with Terraform, that's pretty easy to do using security groups. Or if you're using a different provider, you can use their equivalent of an AWS security group. And so in this situation, I've got this already set up. And let's see if we have passing tests right now. Oh, yeah, sorry. Yeah? Okay, good. There we go. Okay. So I'm just going to run my tests and see what's passing right now. I've got, is this big enough? Okay. Yeah, so I'm going to run, basically this command it's running my inspec tests. It's pointed at AWS in a US West 1 region. And I'm using these testing credentials that I set up, which is basically I've given inspec the ability to read everything everything in my AWS account. So I'm going to run this and see what happens. Okay, great. So you can see I've got a whole bunch of other tests as well, but it looks like the one that I just uncommented is working, which is good. So let's imagine that I just wanted to change this to something else, and I wanted to make sure that no one could get into port 22. Okay, so if I rerun it, it should fail. Okay, so I've got a failure where it's basically affirming that it's not able to get through on port 1, 2, 3, 4, and it's right now I'm allowing a connection on port 22. So what I do is I go over to my Terraform code, and I want to change this. So I want to change this to 1, 2, 3, 4, and I'm going to run Terraform plan. Okay, and so this plan output basically shows you what it's going to do. So I've got a module set up for this that this Bastion's part of. So it's referencing that as module peer test AWS security group, and then it shows you exactly what it's going to do, changing the port to 1, 2, 3, 4, etc. And so let's go ahead and apply that. Okay, so it says 1 changed. Great. So let's go ahead and let's try our tests again just to make sure that things are passing. Perfect. Okay, great. So we did that. We were able to modify something via like TDD. So let's try something else. Let's go. So as part of PCI requirement 10, we're supposed to track and monitor all access to network resources and cardholder data. So let's go ahead and implement CloudTrail. And the first thing I'm going to do is I'm going to write some tests that say that my CloudTrail should exist and the, let's see. Okay, yeah, so my CloudTrail should exist and its bucket name should be a specific bucket name, okay? So this should fail. Okay, so I got 2 failures. One for the CloudTrail not existing, and the other for the bucket name not being correct. So we'll go over here to my example, which I already coded this all up. Basically, and I'll uncomment it so we can see it. Basically, it's going to implement a CloudTrail and set the bucket name to this bucket that I'm creating. And I'm defining the policy in this JSON block, which is going to give CloudTrail access to it and to be able to write to it, stuff like that. So let's go and do our Terraform plan. Okay, so you can see it's saying the plan is that it's going to add 2 things. You can see that it's going to add a AWS CloudTrail instance and then also the bucket. It's going to set the CloudTrail bucket to the correct bucket, and let's try it out. And it's good. So again, we created the CloudTrail and the bucket. So let's run our tests again because we defined some tests right here that were failing previously. So I'll go ahead and run my inspect tests again. And it's all successful. So there you can kind of see a really simplistic way of doing TDD against the PCI spec. You can slowly build out resources with inspec plus Terraform Obviously, you're able to do the same thing with Inspec and Chef, but this kind of gives you an example of, I haven't seen too many examples of that. Yeah, that was a little demo. I kind of wanted to go over a few key takeaways from this. Basically, I guess how I like to look at PCI is that it's an opportunity. I mean, you could definitely look at it as something to dismiss or just some red tape, or maybe it doesn't go far enough for you. But really, it's an opportunity to take a look at your baseline security and get it all in order. Basically, get your entire your business in order and how it handles cardholder data. Basically, you want to limit the scope, the PCI scope, as much as possible, because however much that scope's going to be, you're going to need compliance around that, and it gets extensive, the amount of documentation and logging and review that you need around that scope. So one thing to do is to consider tokenization, so you're not dealing with the cards in your entire infrastructure. So for us at ActBlue, we use AWS to rapidly deploy compliant architectures. We found it to be a really good way to do that. And it's because Terraform has such a feature-complete provider for AWS, it's pretty easy to build things out using Terraform. And from what I've heard, whenever a new AWS feature comes out, it's within a few days, there's a PR for a Terraform, like equivalent of that new feature. I've seen that happen. So it's a pretty good combination. Like whether you're using Terraform or whether you're using CloudFormation, it's good to get your architecture into code to kind of avoid the drift that happens over time as you're like making manual changes, and to kind of provide that transparency that that you want, because you definitely don't want certain things to be siloed with certain people, which is a good thing to avoid. So the Inspec ensures that your infrastructure remains compliant. It allows you to easily test your remote resources. So we could conceivably hook this up to a production instance or cluster and be testing off of that. And also it kind of helps you avoid compliance theater, where you're compliant, but you're not really. It doesn't really mean anything, because your tests are really security tests, and they're being run on a regular basis as part of your PR process. So and you're able to make those compliance tests matter. So yeah, thanks for listening. I think I finished a little bit early, but yeah, if you have any questions, I'm happy to answer them.
What automation are you using to apply your Terraform? What any? Like automation for applying collaboratively Terraform?
Oh, meaning like between developers, or?
Yeah, between the people that write the Terraform code, and like what manages that for you, or you're just running it on your laptop?
Yeah, we right now we're just running it. We use like remote state to kind of manage it between the developers, but we don't actually automate the running of the Terraform yet. That's kind of a next step for us.
So I don't know, like, have you tried AWS CloudFormation versus Terraform? So I'm like curious.
Versus Terraform?
Yeah, so what are the reasons not using CloudFormation, or any comparison have you tried?
Yeah, so we wanted to remain as vendor neutral as possible. And from my experience with CloudFormation, and I attempted to implement our IDS with Terraform, and that was really clean and well organized. trying to do that with CloudFormation, I think that, and people can correct me if I'm wrong, but I think originally it was primarily like JSON-based orchestration. Now they have like YAML, so it's a little bit more organized. So I've found that Terraform code is cleaner and easier to work with personally, and I like the fact that it's vendor neutral, so we can have shared code between if we wanted to use GCP as well or some other provider, we can have shared code behind that pretty easily. Whereas CloudFormation, we'd have to have some sort of separate tool to do that. Does that make sense?
Yeah. And the another question I have on the inspect, so you are running for TTD, but like, are you using some dashboard or looking at the output of all the tests you ran or something? Like,
what's that?
Do you have any dashboard, like having
dashboard.
For
No, we don't have a dashboard for that right now.
Okay, so you're not using any automate or any other things?
Not right now, but that's definitely something that we want to move towards. Yeah, using automate for sure.
So when you're running the inspect, are you actually running it against the Amazon APIs instead of running it against an instance? And if so, is there something special you set up in your account? Is there certain permissions or a policy you need?
Yeah, so we actually do it two different ways. We can set up, like we have a separate AWS account for testing out our changes. So, and actually I've found that to be really useful to have a completely segregated account where you can replicate exactly what's going on in the same regions with the same setup, and you can test your changes directly against that. We can also use inspect to test directly against the production boxes as well, and like you just need to set up an IAM role to be able to read from all of the AWS resources. Is essentially what it is.
Is there a special driver for inspect, or is it all built in?
I mean, you just have to download. I mean, like we use the gem, so you install it via gem. There's a lot of different ways you can install it depending on your platform, but yeah, you just have to give it access. Like in our case, we give it AWS credentials, and then it uses those to access. And that command that it points it at the region and uses the specific AWS credentialed user to be able to access those resources.
You talked about limiting scope to the PCI
Yeah.
Architecture. What does that look like for you? Like how many machines or what percentage of your environment do you have to do the PCI compliance for?
Yeah, so in terms of percentage, we probably only like 10% of our architecture is PCI within scope. So I think that's pretty good. We leverage Fastly a lot, so we kind of have this, like the number of web servers that we should have would be like way higher probably. So it would be more like maybe 5% would be PCI scope or 2% because we're so heavily leveraging Fastly. Yeah. Yeah, I mean, if you guys have any other questions, just come on up. I'm happy to chat. So.
Okay, thanks very much, Nick.
Thank you.